Welcome everybody! We got a fun one for you today. What we have here is basically, it's a Dell H265AM. The 265 means 265 watts. And we are looking at an ATX, also known as an AT or an XT power supply. Basically, it's a power supply for a computer is what you're looking at. Basically, it's what makes it, there's a lot that goes into it, but pretty much it's what you got is there's a feed or sense wire coming off of your motherboard that actually communicates with this via your plug-in right here. And that's why you'll see I have these two shorted. This is going to be gray and black, black being ground. So I have that shorted, and when that gets a pulse of being short, that's what happens when you go up to your CPU unit and you hit the on off button, or to turn it on you hit the on button obviously, and it drags it down to ground. And that it picks that, senses that, and that's what kicks this power supply on. So I got it plugged in right now. I kind of got everything out of the way that I can. Got wires dangling here, but now I do have it shorted here, and like I said, doing that is what's going to hold it on. So now there's some that it's the gray wire, some that I believe it's the green wire. One time I found it depends, you know, which wire. And sometimes you don't have to hold it to ground the whole time. The other one earlier I worked on a while ago, you just always hold it to ground and it would stay on. As soon as you lost that 5 volts being pulled down, it would shut right back down. So it would sense that 5 volts again. Like I say, it senses it. So, well, it's hooked up, plugged in an isolation transformer over here. Get my meter on. Start AC and see what our input is. But now before I flip it on, there's one thing I want to do here, and I pretty much just want to make sure that it isn't shorted at the inputs. So we'll come over, we'll just do the back side, and this is our IEC connector here that I'll be probing, and it goes, the center one, it goes beep beep, and then a center one here. The center one is your ground or chassis ground, and your two outside ones, it's AC, so it's going to be not short. Come on, stay on it. Yeah, 0.44K, so right, was that K? It keeps flipping through. Let me see if you guys can see it. It ain't gonna help much because it just keeps wobbling through numbers. Now that's showing a short, or just about a short. At least the transformer. So we'll go right to the bridge rectifier, which you follow these wires here that are twisted. These bring you right in to the board over here. They work their way back through to here. You go through some filtering, some common mode chokes. Basically, is each wire is wound, one wire on this side, the opposite wire will be wound on this side. And the field that's created on that iron, that ferrite core, any field that's created will be canceled by the other one. And that's by how many windings and how thick the wire is and everything else. It's the frequencies that you'll be canceling. You see two of them here, and it just helps clean up your signal, does the filtering, and then our bridge rectifier. And the side that has the chunk out of it is always your positive. Then you have two ACs, which will be our feed in. This is AC still. And then the outside one, the opposite, furthest one from the positive, is our negative. So we want to go between We'll go diode mode. Get it there. Oh, wrong one. Come on. Oh, yeah, hello, select. Select might help, huh? Alright, this thing's jammed in there. That's going to be hard to get at. So let's see if this is short. It shouldn't be short. Okay, so that's good. Now it should be open this way. Yep. Now, doing the negative side. Open, and now if I flip it, yeah, 0.4, so that ain't showing a short. Oh, you know what? I'm wondering, I see that we got a class X, class Y right here, the little blue guys. You can see them. They look like little muscle men. They're freaking jacked up little blue capacitors. I wonder if them are picking up enough to bounce this around and kind of show that it's a short and then it's not. Let me go across the wires again. And I got I think this is the actually class, well, they both can be class X or class Y, it depends. But the capacitor here on top, that's the AC capacitor. Yep, I bet you that's what it is. So at least we're not showing a dead short or anything. So besides that, I'll just check the our operation, our run transistor, or FET, whatever it is. You never know sometimes. Now, is this one short, or is that just going through? Ooh. That's going through another suppression capacitor on this side. We got a fusible resistor here too. It runs through, so it goes fusible resistor, common mode choke, capacitor, another common mode choke, a smaller one. What is this? This is probably a MOV. It's yellow disc capacitor, and it has a heat shrink around it, so it's hard to see. Could be for inrush, NTC, or PTC, NTC. And it's hard to say without looking that up. I can't tell. I'm guessing that's some type of little capacitor. Two little filter capacitors here. But this diode here, this is a rectifying diode on the other side, is showing dead short. Now, that could be something interfering with it in circuit. Now, it does look like here I have a PTC. Or not PTC, MOV. I get them confused still. I just want to check, and then one of these is going to be my, probably a big diode too. One of the, that looks like a FET in the TO220 package, or 223, whatever it is, the bigger one. Let's see if we can't get in there and try to get some diode test to see if anything's short. Yeah, that's reading good. Why would they glue the leg like that? That's weird. So I'm just doing in diode mode. Just checking. You should be open one way and then the other way. Technically, you should have some type of diode drop. Is that open, or is this burnt? There's something black here. Or is it? Oh, it might be a little ferrite bead that's on the. It is. I'll bet you my little pins get stuck right in it. In fact. Yeah, so it's a little ferrite bead just to knock off a little bit of frequency, unwanted noise that could be on that leg, that inside leg. So now I'll go to the outside one. 0.8. So I think we're pretty good here to. Open. Open, and then I gotta flip it one more time, and I should be, Now remember, once you go through your diode here, it should be rectified. Now that's reading open both ways. It's really hard to tell where you're at here if you're on it or not. But I think we're safe to say that we can plug it in and start checking our voltages. Now we got a whole bunch of voltages that are gonna be hanging on these. I'll try to get this so you guys can get a good look at it. If anyone needs to pause, save it. This down in here, the circle with the lines through it, I don't have any gray, so that means gray. So hopefully that helps someone out, and we'll get it plugged in and see what we can come up with. Get this. I want to get this set up for DC. Get it in waveform mode. Now I got these stripped just a little bit, these wires, but as you can see, I got them at different lengths as I clamped them here. That's in the shot, right? Hello. Oh, just out. Just gonna move it. Hard to see with such a small. See, I got them clamped, so I can at least get on the end and test them. Then I'll try to keep this somewhere we can see. I got my pins that will fit right in there and test them. As long as you're just checking. Once black is your ground, and then, in fact, I'll mark my grounds real quick, so I ain't got to fuss and keep flipping back and forth and forgetting what's what. 1, 2, 3, right there. This one on the end. 1, 2, and 3. So number 3 here is then green, then black, and then black, and then black. So it looks like it's going to be that one right there. 1, 2, yeah, it is that one. So this one is empty. Okay. So I'll put a little mark right there so I'll know. Then it's red, 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 and then this end one. So that should be enough to get me rolling here to start testing them. Mark 3 reds. Reds will be my 5 volts. Now you got 2 different 5 volts. The one, your main 5 volts, the red is going to be up to, what does it say, up to 13 amp on this unit. So that's going to be its max now, max output. So you got the 2, 3. You got the positive 5 volts, and then you got the negative 5 volts. And then you also can have, which this one looks like it does, the 5 volts, which is the negative will be white. And then you'll have real weak 5 volts for like a sense wire, which is, says actually that our green is a 5 volts, positive 5 volts. But so is purple too, so not sure. There is, I thought I seen a purple. Yes, there is a purple in here, so we will find out. And then our orange is our 3.3 volts, and that can be up to 10 amps. I'll get them marked. Them are on the end. This end. You can look these up right online for ATX power supplies, and they'll show you the layout for these connectors. The connectors on these. Hope everyone's doing swell out there in tubage land. Getting out, hopefully back to, hopefully settling in, everyone is, I hope. Hope the best for everyone. And a couple reds, and as long as I got most of them. Well, I got the green right here. I'll mark the green. if you get time, it's actually nice to mark even this side. Then you ain't gotta follow it. And it's weird looking at it straight on like this. Sometimes you'll go to the end and then figure you'll get mixed up. At least I do on what side it was on. If it was on the near side or far side as you're looking across it. That's why I try to be careful with it, so I don't do that. I know that I'm prone to mistakes, so I try to recognize. Green, blue is over here. Oh, I do have blue right there. Oh, mark it. There it is. I didn't say what my blue is yet, did I? Blue is the negative 12 volts, and that's going to max out at half an amp, at 0.5 of an amp. There's our empty. Our gray is right here. Again, I just had like dotted lines. And then purple. Shoot. Ah, purple's the worst. This is what I have to use for purple. Because I have nothing else that remotely purple. It's like paint. Make your own paint with this. That's what this is. All right, plug-in time. Finally there. Get this where you guys can see it, hopefully. Where we all can see it. Okay, action. We are live. Got it run through my watt meter. 0.00000. Nope, 0.1 watt. Looks like, so pretty much a 0. I'm not testing yet. Because if I'm not drawing anything, there's no reason to be testing. Because I know I got nothing. So there's definitely not going to be any AC going on. Huh, so that would be my startup ain't right. So I gotta look here. Gotta be careful too, this is live. But again, it's with the isolation transformer. It says PS on is green. So I got green. And I went gray to ground. Gray is PS on, so it says gray and green is PS on. And I got it pulled to ground. So we're going to go gray and green. Green is one on the other side. Maybe I put it in the wrong one. Oh, yep, that kicked it. That got it. 1 watt. Now, maybe I lost my connection here. Let me get this in here so it'll read a signal if we get something instead of it was just reading a mess there for a second. Okay, I got 1 watt. So it tried to start. I might not have it all the way in here. Or I could have popped it. It has a reset switch. Boy, everything's so... That's the one thing with these is they're tough to get at and get on. So it did try to start. I had it up to 30 some watts. So we know that that is definitely the one. Now, shoot. Oh, it come right off. Damn wire's so stiff. So I'm going green and gray again. Here's my gray one, here's my green one. Watching the, okay, 22 watts, 66 watts, and then I lose it. So it's kicking and then it's dropping out. So could be our output, one of our outputs is possibly shorted. So that's going to take some fault finding. So we're 1 watt. 1 watt is not going to do it. And I'm not getting my voltage on the yellow, which is my 12 volt. Plus 12 volt, and that's 9 amp or 17 amp, depending. Now, I did say this is a Dell H265A, so 265 max watts is what that is. AM, I'm sorry, 265 AM -00. So here's our ground. Let me try my orange. What do we get with the orange? Got nothing. White. Yeah, we're still at 1 watt in red. So I want to shut it down. Now, taking a look here is what I did notice as I was pulling this apart to work on it is something right here. I did look at the back of the board. On this side, it's a pleasant just mess of components, but I didn't see anything alarming. Nothing at all, nothing to raise an eyebrow at. So I ain't too hesitant and worried. Really, nothing obvious, we could say. Over here, now it did have this foam on it, and that leaves behind little wrinkle things, like if you're looking real close at it, like here or here. It makes it look like a little crusty spot, but it's actually not. They're kind of a false alarm. But let me see if I can't bring you guys in and show you what's going on here with this. You see the resistor is pretty toasty. You can tell it's gotten warm. So I wonder if we got some action going on with it there. See that right where this guy right here. I got everything hanging from it, but see how it's blacker on the board there? And there's 2 transistors or transistor looking TO92 package type deals there. So I got it shut off. I'm gonna drain this main filter cap here coming in, electrolytic. I don't know if anyone's seen it yet, but that's my fancy trick for getting these to burn off. I don't like to short them. I never have. Is what I got is I got a little microwave. Oh wow! I got you way freaking knocking the ceiling apart pieces. Got you way too zoomed in, and you just short out the 2 wires here. These are just lead wires, and the nice thing about it is you'll know if there was juice in it. It'll light real dim and then it'll drain right off, so you know that you drained it. properly instead of just sparking it over and not knowing whether you got it all. And that's not good practice for the capacitors anyway. There's a big form if it's bad form or good form. I mean, it can't be healthy. I mean, come on. You're just zapping the things. So, I mean, maybe it doesn't hurt them, but it sure don't help them, I can tell you that. Getting on it is another thing. So, nothing there. Like me brains! There's nothing there, they says. Went to the brain doctor. And I said, is everything alright? He says, yep, I found nothing. I said, I knew that. I knew that. That's the problem. Oh, just funds. So, I want to check them TO92 packages. I couldn't find a pinout on them unless there is printed on them. Nope. 431AZ. The other one is a KS something 2222. What is the last one? I just can't get it. The Glare A? 2222A or something. Pretty sure that's just a regular 2222. Isn't it 2N2222? So I want to get diode mode again. Select. So there, yep, diode mode. Wires unwrapped here. I'm trying to make sense of what's going on here. This is just because I see a lot of heat going on. I got gold on the end, I got red. It's just so hard with them. Red, brown? Brown, orange? Yeah, I can't tell. With the black and the gold. So it's going to be a small, very low, you see that? 0.2. Okay, I'm on the middle one. I'll go to the end one. And this one and this one. 0.6. So that one seems, in circuit, it's reading good. In circuit is just a kind of a trial by fire test. Really, to test it right, you want to pull it out of circuit, but... So what do we have? That's 0.8, so we do have a voltage drop. So we got negative, positive. Now which one's it going to be? Nothing.